Today we're going to talk about how to graph linear inequalities. First, let's talk about what is an inequality. An inequality is not equal. So that's where we see our less than or equal to, greater than, and greater than or equal to symbols. What does it mean if a graph is linear? So linear inequalities we know have these symbols. Linear means that it makes a line, it has a constant slope. And when we graph linear inequalities, sometimes we have a dotted line and sometimes we have a solid line. Just like when we graphed inequalities before where we had to have open or a closed circle, dotted line would be when we have less than or greater than. It is not equal to, so it's dotted along that line, it's not equal. And then solid line would be greater than or equal to, less than or equal to. So if we see a solid line, the line will also be solid. If we don't see one, it will be dotted. So now we're going to look at some examples. We follow these steps. First, determine if the line should be solid or dotted, then graph the line like usual. Test a point. Our test point is going to be 0, 0. The only time we can't use 0, 0 as a test point is if the line goes through that, and we won't worry about that today. And then determining if that test point is true or false will tell us which way to shade. So our first example, we see this is in slope-intercept form. We look and we see this is less than or equal to, so it's going to be a solid line. And then we graph this just like normal. I start at the y-intercept of 1. And our slope, remember if there's no number here, is 1 over 1. So up 1 over 1, up 1 over 1, up 1 over 1. And it's a solid line. So that means I can just connect these to make a nice line. Okay. Test a point. So 0, 0 is the easiest test point because we put 0 in for y and we put 0 in for x in the equation. So this really says, when I simplify, 0 plus 1 is 1. 0 is less than or equal to 1. And we say, is that true or is that false? 0 is less than 1. That is true. And if it is true, we see that point 0, 0 is right here. And that is true. So that means we want to shade that side of the line because that 0, 0 is a solution. Everything in this shaded area is a solution. So I could test other points like we did 0, 0. I could test, let's see, -5, 2, and that should not work. It would not be a solution. All of the solutions are in the shaded area or on the solid line. The solid line is included, a dotted line is not. So all of these points down here, if I had to name a solution, I could say, well, we know 0, 0 is a solution. I could also say maybe 3, 1. I could say 2, -2. Okay, there's a lot of different points in this shaded area below this line that are solutions. Okay, let's look at another example. This one I notice is less than, so it's going to be a dotted line. Graph it just like usual. Start at the y-intercept, -1. Our slope is -2, so I'm going to go down 2 over 1, down 2 over 1. And instead of connecting with a solid line, I'm going to connect with a dotted line. That means that anything on this line is not included. It is not a solution. Okay, that is where it would be equal in the equation, and we are not including the equal part. So to figure out where to shade, we need to test our point 0, 0. So I can put 0 in for y and 0 in for x. Simplify, this just becomes 0 minus 1, so -1. Is 0 less than -1? No, that is false. 0 is not less than a negative number. So we tested 0, 0, this point here, and we said that's not true. That means we don't want to shade it. So I'm going to shade the opposite side of the line. We don't shade if it's not a solution. Okay, so when we test our point, remember, if it's true, we shade it like we did here. If it's false, we don't shade it. We shade the opposite direction. Again, I could name any solution in this area. A solution would be, let's see, -3, 1, or -5, 0. Anything in this shaded area would be a solution. This one we have to use the cover-up method. Before I do that, I'm going to notice that we are going to use a dotted line because I don't have the equals part. I cover up 3 divided by 1 is 3, 3 divided by 1 is 3, so x and y intercepts are both 3. Connect with a dotted line. It is important when we graph to go all the way across the graph. I know sometimes when you only have these 3 points, you like to stop your line here, but then that's not really showing us the entire solution area that's shaded. So we need to make sure our lines extend with our rulers all the way across the graph that we are provided. Now we get to test a point. So this one looks a little different, but we still put 0 and 0 in for x and y. 0 plus 0 is 0. So is 0 bigger than 3? No, that is not true. So remember, here's our 0. We said that is not true. We don't want to shade it. So we're going to shade the other side of the line. This one is not a solution, so it does not get shaded. If I had to name some points in the solution area, I could say 3, 2. I could say 1, 5. Okay, and so on. Anything in that shaded area is a solution. The dotted line is not a solution. The solid line is a solution. Okay, and that is how we graph linear inequalities.